In section 9.3, we looked at tangent planes. So when looking at a three-dimensional surface, f of xy, we said we can approximate the values of this surface with a plane by using this formula above. So again, this is called the tangent plane, sometimes called the linearization of your function. So what we do is we start taking partial derivatives of our function and evaluate them at a comma b. So essentially these two numbers are going to be constants, and we then add the value of the function, and this will give us the formula for the tangent plane. So let's look into finding the tangent plane to the following surface. So here's an extra one. Let z equal to the natural log of x minus 2y. And let's find the equation of the tangent plane to the surface at the point 3, 1. Okie doke. So first, notice that I don't have f of xy there, but it pretty much is the same thing. If you have a function, then f of xy and z are interchangeable. So we can talk about the partial derivative of z with respect to x and the partial derivative of z with respect to y. These would be like my partial f partial x and partial f partial y. Here I have a composition of functions. The derivative of the natural log is 1 over the argument. Inside the argument, put in the original argument. And then we're taking the chain rule derivative with respect to x of x minus 2y, which is just going to be 1. For the partial derivative of f with respect to y, same sort of deal. The derivative of the natural log is 1 over the argument. Put in the original argument in there. And take the chain rule derivative of x minus 2y with respect to y, giving you negative 2. Now, we'll take these partial derivatives and evaluate them at 3, 1. So this is 1 over 3 minus 2 times 1, which is just conveniently 1 for this guy. For this other guy, we'll have again 1 over 1 times negative 2. That's negative 2. All right. One more thing that we need is the value of the function at 3, 1. So that's equal to the natural log of 3 minus 2 times 1. That's equal to the natural log of 1, and the natural log of 1 is 0. So the linearization of our function is equal to 1 times x minus the x coordinate that you're centering this analysis at, which is 3, plus negative 2 times y minus the y coordinate that you're centering this analysis at, which is 1, plus your function at 3, 1, which is 0. Alternatively, you could have written this as z equals x minus 3 minus 2 times y minus 1. That's just an alternative way of writing it. So you can replace that L of x, y with simply z. So again, this plane is a good approximation to your surface when your x's and y's are close to 3, 1.